All right, so our first question on the review is asking you to enter your data into your stat part of your calc, into your lists, and then it's going to be really clear as to what kind of regression you're supposed to come up with. It'll be the same way on the test. Now, I'm not saying it's the same kind of regression. You're going to have to choose carefully when you're in that menu. But your first task is to get the number of weeks and the population of the ants entered into list 1 and list 2. I'm going to pause the video while I enter mine. Please do the same. So I have my data entered into list 1 and list 2. And then please notice in the chart for list 2, it's the population of the ants, but it's in terms of the 100. So like 15 represents 1,500 ants. They just kind of simplified the data a little bit for us that way. Now it does, if you continue on reading, it says let x be the number of days, y be the population in hundreds, write a regression equation for the logarithmic model. So when you go to choose your regression, so stat over to calc this time, logarithmic regression, which sometimes kids get a little confused, you have to go down here to number 9. That's natural log, so logarithmic regression. Do not confuse this with logistic regression. That's our logistic growth. It's different. And if it says exponential regression, hint, hint, like it does on your test maybe, make sure that you're using exponential regression in that case. But for here, logarithmic regression would be ln. My data's in list 1, list 2. There's no frequency list, and of course I like to store my equation into y1. Oops, not that. All right, varies over to y varies. You could probably get away with not storing it on this question as long as you keep enough decimal points, but you know, whatever. All right, so there's the formula. It tells you who to plug in for A and then for B, which is the coefficient of the logarithm. The regression is really good. The correlation coefficient, I should say, is really good. So that's another double check. Like if you get a weird correlation coefficient, that probably indicates you chose the wrong command on your calculator. So keep that in mind. I'm going to jot that down on my paper. And I wouldn't do anything to simplify anything in this question. I would just write down what you saw. So the A value, what was it, 15.01? Plus the coefficient was 19.99. And then times the natural log of x. And then how many ants will be there after 35 weeks? So because you stored it into y1, you could easily go to your table. But you just need to somehow plug in x equals 35. And then your answer comes out to, now on my calculator, 86.09, but remember that's hundreds of ants. So I guess a better answer would be, like, multiply that by 100, right? So like 8,609 ants. And again, it's an approximation. We're talking about ants, it's not life or death here. Alright, so moving along, the next question is a logistic growth, where they give you the formula. It's about the population of deer in a park. And the formula is given to you, and what I would suggest is you start this question off by typing this into y1. So make sure when you get this entered into y1, you put parentheses around that denominator. I'm going to pause the video. You go ahead and enter while you also pause the video. So I have my function typed into y1. Everything else is cleared out. And they want me to find the initial population. When will there be 100 deer? And then the projected maximum. So that last question you should be able to answer without really doing any work. You're welcome to go to your table for the first question, but you're going to eventually want a graph. So what I'm going to do is I'm going to set my window. At least I know what x should represent. X is how many years have gone by. So usually 10 years is usually pretty good. So I'm just going to leave it at 0 to 10, and then I'm going to try zoom fit. See how I like that. It might be terrible, I have no idea. It's not bad. Alright, so they want to know first the initial population, which is time of 0. So you could plug in a 0 yourself, or you could hit trace 0, or you could go to your table, but there's about 27 deer. So we're going to write down about 27 deer. And then the next question, when will there be 100 deer? So you could trace, or what I usually do is I just go to 100 into y2, and I need to figure out where they intersect. So second trace, intersect is my favorite one because all you got to do is hit enter, enter, enter. So roughly 2.25 or 2.2 years is fine. It even says on there to graph. That's nice. All right, and then the projected maximum number of deer you could trace and kind of see where it's flattening out, or you could remember that in logistic growth, this number in the numerator is the projected maximum, because logistically they only have so much resources. Or you could, plug in some really large number, like 200 years later. Just make sure that you're either on your table or you've extended your window for that. But either way, the answer comes out to 1,450 deer is the projected maximum. So a bunch of ways you could find that. I didn't write down any of those answers. Let's see, this was about 27 deer. Make sure you're labeling these, please. When will there be 100 deer? That was, what, about 2.2 years? Say the word after, that would be nice. After 2.2 years. And then the projected maximum is 1,450 deer, which you could easily just pull from the formula. All right, so now we're going to be using straight algebra skills, and we're going to be solving logarithmic equations. You will no longer be doing any graphing. Make sure that you're using appropriate algebra skills and you're showing your work. So this first one, these are those nasty questions where they're trying to emulate a trinomial, like a factoring question, but they have this weird e to the x power thing. So you look in the middle of your trinomial, and we're going to substitute that variable for u. So, or that function, I should say, e to the x power. So u is now going to be e to the x power. So this guy right here is really like 3 times u squared. So that's what I'll write down. 3u squared, and then minus u, minus 10. And that's a much simpler trinomial for us to factor. Let's see. Obviously it's 3u and u. 5 and 2 sound like good options. Let's make this a -2 and a +5. That would add up to -1 in the middle. And then if you set each of these equal to 0, this one gives you u equals -5/3, and this one gives you u equals 2. But we have to go back and remember u is actually e to the x. So this changes back to e to the x equals -5/3, and this one changes back to e to the x equals 2. I don't know why I switched to blue there. Let's try that again. Alright, so this first equation that we have set up, e to the x equals -5/3, well, if you go to apply a natural logarithm here and here, you're going to end up with a non-real answer, an error, because you can't apply the natural logarithm to -5/3. So that's an extraneous factor. But here, if you apply the natural log to both sides, natural log and e will cancel, and you get your first answer, which is x equals natural log of 2. When they say the exact answer, that's what I'm looking for. And then they want you to type it on your calculator. So the natural log of 2 typed on my calculator, rounded to the nearest hundredth spot, is 0.69. Alright, this one. Alright, we cannot exponentiate yet. There's too many logarithms going on here. So I think, you know what? I think on the review we changed this to a plus. So if we were to condense these together, because that's the way it is on your test, that means we're going to multiply them together. Oh man, I hope this turns out alright. X squared minus 7x. Yeah, it should work out. Alright, so you end up with log base 4 of, when you condense log plus log, it turns into a multiplication problem. So x times x minus 7 would be x squared minus 7x. And then we're exponentiating both sides technically with a base 4, or you could use the one-to-one property of logarithms, which says these just cancel out. And you end up with the quadratic of x squared minus 7x equals 8. So I'm going to make a little note here to myself that we changed the problem. So if anyone's looking at my slides, they don't think I'm nuts. Alright, so let's quadratic. So we got to subtract the 8 over and factor. Hopefully with me changing this, I didn't make it unfactorable. Let's see. Ah, that should work out. X minus 8 times an x plus 1. So you get two solutions right now, x equals 8 and x equals -1. However, when you go to plug in 8, you're good here and here because you can take the logarithm of positive numbers. But if you go to plug in a -1 right there, we're going to have trouble because it'll be log base 4 of -1, which cannot happen. So that's an extraneous solution, and the only solution that we get to keep is x equals 8. If we kept the problem the way it was, it would have turned into a division question, and you would have ended up with no solution, which is okay. That happens, but that's not the way it is on your test, so I wanted to make sure we had one on the review that looked like your test. Alright, number 5. This is, again, like your test. We're collapsing these down. We know we're supposed to multiply the inside stuff together, so that becomes x squared minus 8x equals 2. Now notice this time, you have to exponentiate, or at least do the rewrite formula. I teach my kids to exponentiate both sides with a 3. So on the left side, 3 to the log base 3's will cancel, and the x squared minus 8 drops down, minus 8x, excuse me, drops down. And over here, remember it's 3 to the second power, so it equals a 9. So when you go to solve that quadratic, again, you got to watch for extraneous solutions, and it looks like we're going to have another one here. You're going to get x equals 9, which is totally fine. I can plug in a 9 everywhere and still get positives inside the logs. But this one is going to be extraneous, because if you plug in x equals -1 to either one of these logarithms, you'd be trying to apply a logarithm to a negative number, which we know can't work. So x equals 9 is the only solution that we need. All right. This one's kind of fun. You're going to rewrite it using properties of logs or whatever you know to be true about solving logarithm equations. If you want to use the term exponentiation, you can. If you just want to use the rewrite formula, you can. But what I teach my kids to do is, okay, if you're trying to solve for x, that means you have to, quote, get rid of the natural log. So we're going to exponentiate with the base e. So e to the, over here on the left side, you have e to the y power. Notation and the way you're writing is really important here, guys. E to the natural log are going to cancel, and you get x plus 7. And then my final step to isolate would be to subtract 7. So I'm going to be super picky about this. You have e, base e, to the y power, and then off to the side is a minus 7. And that's what x equals. So sometimes kids get a little sloppy with their handwriting and, like, you know, whether something's superscript or subscript or it's on the main level of the equation. So be careful about how you're writing that, please. Oh, everyone's favorite, Newton's law of cooling. So remember, these are the questions that have 2 parts. So part 1 is where you're going to calculate to try to find k. And then you're going to use k in part 2, where you're going to find a t. So in part 1, for both parts actually, it comes out of the oven at 350. So that's the initial temperature. And then the first time, it's going to cool to 260. So that's the final temperature for part 1. So I'm going to make a little note there, 260. In a 71 degree room. So that's the temperature of your surrounding medium, which sometimes in our notes they called it T sub S, but in this formula they call it T sub M. And that's going to be the same for both parts. But then keep reading. It does say, eventually I want you to figure out how long it takes for it to cool to 125 degrees. So 125 degrees is going to be your final temperature in part 2. So we just have to be careful. And of course T and K are going to be switched out. So starting my formula with final temperature of part 1 of 260 minus the surrounding medium of 71 equals the quantity, and then it's initial 350. I did not give myself enough space. Minus the surrounding medium, which is 71. Erase this a little bit. Goodness, what was I thinking? And then times e to the negative, and it does give you a time somewhere here. 19 minutes right there. I kind of missed that. So it's negative 19 times k, because I don't know k. All right, so a little calculation here. We're going to simplify this part and this part. You think I wrote this down, right? All right, so we got 189 equals 279 times e to the negative 19k power. I'm going to divide both sides by 279. And then for me, on my calculator, I just keep using the small decimals. I don't do any I don't write down a decimal, I just keep all my work in my calculator. My next step is going to be to apply a natural logarithm to that number, because when I apply a natural logarithm to this side, they cancel. That's nice. So natural logarithm of this fraction or decimal is roughly 0.6774, and it equals negative 19 times k. So a final step would be to divide both sides by negative 19. So we get a k of approximately 0.02. And at some point you're going to have to round and truncate. It'll tell you where to round on your test. I think it says to the hundredths place here. So that's part 1. Now we got to go through and do part 2, but the difference is we have a new final temperature of 125. And then the surrounding is the same. The initial, we're still going to count from out of the oven. It does say in your test to count from out of the oven. So 350 minus 71. But this time, we know K, we don't know T. So it's negative 0.02 times T power. But the work looks really similar. So we have a new number here. What do we have here? I don't know. I didn't write it down. So I know this is 279. So whatever this number is, we divide it by 279. I should be able to subtract that, huh? That's a bummer. All right, let's see. 54? Is that a 54? If it's not a 54, I apologize. All right, so we have to apply the natural log next. So we have the natural log of what I hope is 54 over 279. And then these canceled. Natural log. Wow, this could not look any messier, huh? All right, so you have 0.1935 equals negative 0.02t. And then dividing both sides by negative 0.02. And you find that from the time it comes out of the oven, it takes 82.1 minutes to cool down. And again, it'll tell you where to round on the test, I believe. I'm really sorry about how ugly that looks. Let's move on. All right, so this question has a half-life, and the formula off of your pink card that you're going to be using is this guy. So the T over H power. So since it's half-life, and they give you a bunch of info here, it says it halves every 9 hours, so that is the H, the half-life. Starts with 50,000, so that's the initial amount. Petri dish, yada yada, they want it to be under 6,000, so that's going to be our final amount. But we'll talk about rounding in a minute. This one's a little tricky. And they want me to find T, so that's, oh, the other thing we did talk about, R. Well, if it's halving, that means your R is going to be 1/2. So 1 minus 1/2 is 1/2. All right, so here we go. 6,000 is where I want my final amount to be at, under 6,000 technically, starting with 50,000. And then it's times 1/2, or 0.5 if you'd rather write it that way, to the T over H power. So I don't know T, but I know H is 9 hours. So we're measuring time in hours, keep that in mind. Let's divide both sides by 50,000. And again, you have to kind of make a decision whether you're truncating here or not. Looks like, oh man, I lost my key somewhere. I have to find that. All right, so I think that comes out to 0.12. So that works over here now. I have 0.12 equals 1/2 or 0.5 to the T over 9 power. So I'm going to go ahead and apply my natural log right now. I like natural log. And nothing cancels, unfortunately. So you get, you're in a position where you have to do a little division. So on your calculator, you're going to have to divide the natural log of 1/2 over to the other side. So carefully type natural log of 0.12 divided by natural log of 1/2. And then you're still not done because it still says T over 9. So after you do that step, which I don't think I wrote anything down, you also have to multiply by 9. So that on your calculator should produce the decimal of like, it comes out to about 27.5. Now, because of rounding, if you round it down to 27.5, you're not going to have a population that's under 6,000. You're going to still be over 6,000. So since it says to the nearest tenth of an hour, you're actually going to have to adjust this to a little more time. You need to go to 27.6 hours. Because if you use 27.5, you're not going to be under 6,000. That's the issue. All right, so careful on your rounding there. And then they want you to actually figure out how far under you are. So using this for T, you're going to calculate. So we have 50,000. And then you have 1/2 or 0.5 to the 27.6, make sure it's 27.6 over 9 hours. And on your calculator, that comes out to roughly 5968 bacteria when you round to the nearest whole bacteria. So the question is not how many bacteria do you have, but how many are you under 6,000? So quick little subtraction problem, 6,000 minus 5968 gives you about 32 bacteria that you were underneath. If you didn't round this first part properly for the question, you're going to notice this answer comes out to 6,000 something, so you're not under yet. So you're going to have to go back and adjust that. All right, and that, I think that took us through the whole review. All right, so good luck. I know we kind of buzzed through some stuff. That snow day put a kink in our plans, but hopefully you've had enough experience doing your homework that you don't struggle through this test.